Hello friend, once again welcome to ashatech.com, and today we are going to discuss what is meant by single and double shear. So we have so far talked about shear stress, and we said that shear stress is given as tau, which is equal to the shear load over the area resisting shear. Now we are going to look at two scenarios, in a single shear and in a double shear. Consider the simple riveted lap joint shown below. This member is being joined to this member by a rivet, and this is called a lap joint. So this is a simple riveted lap joint, and if there is a failure, for example, if you applied forces and there is a stress, a shear stress tau, it means the object or this rivet or this pin is going to fail in actually a single plane. It is only one plane that is going to indicate the failure of the rivet around here. So when the load is applied to the plates, the rivet is subjected to shear forces tending to shear it on one plane as indicated. Now if we are to discuss that in details, we shall see that we have that member being joined with this using a rivet. Now there is a force that is applied there and here to see that this system is under shear. So if it is under shear, this pin here of the rivet is going to fail in one single plane. So that would mean the shear stress tau is going to equal to the shear load. If this is maybe 2, load 2 will be the shear load over the area resisting shear. Now when you look at this, if I take, because this shear stress is equivalent to this one, so if I take one piece, it means that that shear stress tau is going to equal to the force 2, if I use 2, divided by area. That is because this single pin on a lap joint is failing or is going to shear in one plane. The plane, I mean, if I drew a plane around here, just in a single plane. Now let us look at what happens when we have a different kind of joint. For example, if we have a butt joint with the two cover plates, this is one cover plate, this is another cover plate, and these are members in which a force Q is being applied. resulting into shear stress tau. Now, when you look at this system, it fails in more than one planes, and there are going to be only two planes. Let me show it like this. This is the plane of failure, and you have another plane of failure. So in other words, in such cases, twice the area of the metal is resisting the applied forces, so that the stress setup is given by tau, which will be the shear load, the shearing load, divided by the total area resisting shear. So we are saying it is equal to the shear load Q divided by area resisting shear, we can look for it. So the butt joint splits each of the rivets is going to be sheared into 3 pieces as follows. This is one, and this is another one. So you can see that you have one like this, and you have another one like that. So if I'm to draw the planes of failure, it will be one here, another one will be here. So I can also draw it like this. So it means that the total area, if this is A, the total area resisting shear is going to be twice A. Therefore, for double shear, which happens in a butt joint, given by tau, will be equal to the total shearing load Q divided by twice the area. So in summary, we have said in a single shear, tau is equal to Q out of A, and in a double shear, tau is equal to Q out of 2A. As simple as that. Thank you so much for watching. See you in our next lecture.